In this tutorial, I will teach you how to make a clean and scalable inventory system for your game. The topics we will cover is adding items to the inventory, dropping an item out of the inventory, dragging and dropping items in inventory in order to A. Split them into two, B. Stack them onto each other, and C. Replace them with each other. So by the end of this tutorial, not only will you learn the logic behind all of these operations as well as the inventory system as a whole, but also how to implement everything here entirely from scratch on your own. So first, let us jump into the logic and then the code, because once you understand the logic, the code just becomes complementary to it. To fully understand the logic behind the inventory system, we need to first look at all of the components at play here. Firstly, we have our item. Next, our inventory, wherein we store said items inside said inventory slots. Now, if you remember from games like Minecraft, you might notice that you're able to stack some items together into one slot, whereas the others like sword, the pickaxe, etc., you are not. That means that every item has their own intrinsic value, which states that how many said items you are able to stack in one particular slot. Of course, not only the quantity, an item will have its own name, its own description, its own image, etc., etc. So let us define all of these intrinsic values of an item in a data class called item data. This is the metadata used to refer an item. Think of it as the blueprint of that said item. That is, using this we can create various instances of this particular item. Okay, moving on. Now let us assume our player wants to pick up an item. Now we cannot directly interact with this data class, or rather this blueprint. It is just an idea. What we need is the physical representation of this idea, a building made out of this blueprint for the player to interact with. So we have another component, that is the visual representation of this item data. Let us call this item, which our player will interact with. Once we pick this item, we put them into our slots. Now again, our inventory slots cannot directly interact with this data class. Same logic as the player. What we need is a UI representation of this item data that our inventory slot can store. So now we have finally another component. This is the last one, you guys can relax. That is, each inventory slot will have a inventory item component, which will store the actual data of the item being stored in this particular inventory slot. So essentially, our inventory system is just the movement of this item data class from its physical representation to its inventory/UI like representation. Once you understand this cycle, the whole inventory system just becomes a cycle that you have to implement. So repeat this portion if you did not understand it. I'm sure you will then. In the meantime, let me move on to explaining the logic behind picking up an item and then writing its subsequent code. Now, as said previously, whenever we mention that a player is picking up an item, it is just picking up a container containing the instance of an item data, filled with its own quantity and name. We then try to fit in this item data into our inventory slots, with each slot being just a container of its own item data. Now the logic to fit in this item data is actually pretty simple in paper. Firstly, we iterate through all of our slots and greedily try to fit in our item. That is, if we find a slot containing the same item as the one we want to add, we try to fit in the item into the slot by trying to fit in this item data until and unless we exceed the maximum allowed quantity that we can stack, which, if you remember, I mentioned earlier, will be unique per item and will be stored in its item data class only. If there is any amount left, we just continue our loop. If there is still some quantity left, we try to fit in any of the remaining empty slots available to us. And finally, if there is still left, we just drop that remaining quantity. Oh, and by the way, we will cover the dropping an item section of the tutorial in the next part. So don't forget to subscribe and stay tuned for that. In the meanwhile, let us now code all of our components and this item picking logic. To set the context here, I just have a basic level filled with some walls and the sun. and just a player node, which is just the template character body 3D node. Let us now work from bottom to top, that is making our item data, then the world item node, and onwards towards the inventory UI. Speaking of item data, it will be just a resource class filled with these intrinsic values: its name, its icon, the maximum stackable amount, and the description. We will then make an init function which will be used to instantiate a new object of this item data class, aka a constructor. Let's say you want to create a template item data. Let us assume wood. So to create any new item data, or rather any resource, we go to create new option and then select resource and then choose the item data inside it. Once the resource is created, we just double click it and change its properties inside the inspector, which in my case would be wood and its surrounding properties. With that item data created, let us now make a world item node. This world item node will be a area 3D having its own collision box and a mesh instance 3D, which will be used to visually represent it in the world, and finally a label 3D which will be used to display the name of the item in the world. For the code part, we first add in the reference to this mesh and the label, and then the reference to the item data this object will contain, as well as the quantity of the said item data contained within this world item node. We will provide these item data and the quantity value whenever we are instantiating this world item node into our world. The next few bits are just self-explanatory. That is, we are just setting up our world item node by updating its label, its quantity, and its item data value upon initialization. Finally, we will also need to add in a function called handle pickup, which will run whenever the player picks up this particular world item node. For all intents and purposes, whenever the player picks up this node, it should get transferred towards our inventory. That is, it should get deleted from our game's world tree. Understood? Okay. Now, speaking of pickup, let us now see how our player handles this pickup logic. Much of the next part is just a extension of my interaction system video. So I will be hand waving a little bit this player interaction stuff. So if you do not understand everything in this player side correctly, I would recommend you to go watch out that video as well to get the full picture. Anyway, moving on. We make a area 3D node called hand, whose job is to detect all of the world item nodes our player is interacting with inside this collision shape and return to the player the one that is nearest to it. For the code wise, it will look something like this. We have an array called items which will be used to store all of the world items we can interact with. Inside our getItem function, we loop across all of this array and choose the item which is closest to the player distance wise. To add in and remove items from this array, we write out that corresponding code inside the area entered and area exit functions. Moving on to the player, we add in the reference to our hand, and whenever we press our pickup button, we run through our pickup item logic, wherein we first pick up the best item nearest to us, run its handle pickup function, and add it to our inventory, which we will handle later. So let us just mark it as a to-do for now. To store items into our inventory, we first need to create the inventory item class. In theory, it can be any node. However, for the purposes of this demo, I am thinking of keeping it as a resource. Similar to our world item class, we will firstly write two variables, one to store the item data and the other to store the quantity that this inventory item is storing. We then write the constructor to instantiate these two variables. We then write the function getRemaining. This function will return us the amount of items left that we can still place inside this inventory item object by comparing our item data's max stack variable and the current quantity of items. We then add a try_add function. In this function, we will try to add in the given quantity amount of items into our inventory item object by comparing it with the remaining space left. And at the end, we return out the leftover items that we were not able to add. This function will make more sense when we wire it inside our inventory's pickup item logic. Speaking of inventory, let us write the code for that. Our inventory will be of base type node and will emit a signal called inventory changed whenever we update any inventory item inside it. This signal will be used to update our UI later on. We then add two variables, one to store the array of our inventory item and the next to store the actual length of this array. So the idea is that we are able to edit out our initial inventory size inside our editor and then just instantiate our array according to it. Next, we add in our add item function. This is the core pickup item logic of our inventory. The parameters of this function is the item data and the quantity of the said item data contained inside the world item node that is given to us by the player. Inside it, we firstly loop through all of our slots greedily, and if we firstly encounter an empty slot, we then create a new inventory item inside the slot and then try to fit in this given quantity inside the slot. If you remember, this function gives us the remaining quantity of the items that we were not able to add. So we just replace our input quantity with this. In the second scenario, if the given slot contains the same item we want to add, we then try to fit in this given quantity inside it. If after any one of these scenarios our quantity of items becomes 0, we have successfully added the item inside the inventory and then we exit out of the loop. And if not, we just continue on with this loop with the remaining quantity of items. In each iteration, we also emit the inventory change signal to tell our UI to update itself accordingly. Again, we will wire that part later down the line when we are writing the code for the inventory UI. We also need to add in one more function called getItemAtSlot. This will be used by our UI slots to get in the corresponding data of the item that they are representing. Finally, to hook this inventory to our player, we firstly add in the inventory node as its child and just add in our inventory item function in the place of our to-do. Okay guys, only two things left. That is the inventory UI and the inventory slot. Firstly, the inventory slot. Our inventory slot consists of a panel of size 64 by 64, a texture rect made to store the icon of our item data and stretched to fit the width of this panel, and finally a label anchored at the bottom right to display the quantity of the said item. For the code part, we first add in the reference to these two nodes, then two variables, one called the slot index, that is the index of the slots that this inventory slot represents inside our inventory's UI, and the second, the reference to the inventory item object this inventory slot represents. We then write some functions to set up this inventory slot. Nothing special, just your typical set item and update display functions to put in the values inside our texture rect and our label nodes. Finally, let us now jump into our inventory UI. Make a new control node and add a grid container child inside it. And just have the grid container contain 5 columns. So in short, we will have a 4 by 5 table. That is 4 inventory slots per column. Feel free to change this as well as the slot size, the slot array size, etc. as per your game. Anyway, the code is just the replica of inventory. Speaking of inventory, we first need to add in the reference to the said inventory inside this code, as that is the backend behind this UI frontend. We then add in the reference to our inventory slot and our grid container objects, and then a slots array to mimic our actual inventory slots. See, I told you before, right? This code is just a copy of inventory. Anyway, to set up this inventory UI, we run a loop using our actual inventory's slot array's size as the range. And for each iteration, we instantiate a new inventory slot scene and append it to our UI slot array and as well as the grid. We then map the inventory change signal given out by inventory to a new function called onInventoryChange, which I will define later. We then write a function to update/refresh/initialize our UI. In this, we just loop through our slots array and set the corresponding inventory slots inventory item with its corresponding actual inventory item inside the inventory using the getItemAtSlot function which we defined way back earlier. And finally, we implement our onInventoryChanged function, which is just a repeat of the previous function minus the loop. Okay guys, we are finally done. Just make sure of these few things. 1. You have added the inventory and the inventory UI inside our player node. and correctly assigned all of the variables inside the editor. Second, you have mapped correctly the pickup item input key inside the project settings. Third, you have correctly assigned the collision masks and the collision layers. And finally, inside the test scene, you have added some dummy world items. And with all of this, we are done. What we have now is a very clean and scalable architecture behind a inventory system and a proper functioning code of picking up items inside this shared inventory. Hope you guys liked this tutorial. In the next part, I will be discussing on how to remove and drop items out of the inventory. I know this video might seem long, but trust me, this will be well worth it in the end. Anyway, in the meantime, don't forget to like and subscribe and comment to boost the algorithm. And I will catch you guys the next time. Okay, bye. Welcome back. In this video, we will be discussing and implementing the logic behind dropping items out of your inventory. This tutorial is the second part of my multi-part series, wherein I teach you how to make a clean and scalable inventory system for your game from scratch. In the first part, we wrote the core architecture and handled the pickup logic of our inventory system. So if you are new to the series, I would recommend you to go watch that video first. Anyway, let us now discuss the logic behind removing items from the inventory and then implement its code. We initiate our dropping logic whenever the player gives the inventory the command to drop an item at, let's say, slot index I. In that case, the inventory does two things. Firstly, it returns to the player the item data and the quantity of that said item data stored within that particular slot. Then it deletes the data stored at that particular index for itself. Next, after receiving the item data and the quantity, the player will then instantiate a world item node out of that same data, thus completing the flow of dropping an item out of the inventory. And as an extension, if you guys remember, in the previous part I said that if we fail to add a set remaining number of items into our inventory, we will drop them. So I think now the logic to drop them should be pretty clear to you. From our initial pickup item loop, we will have the inventory return to the player the remaining number of items that it was not able to add. In that case, the player will then instantiate back a new instance of a world item using this remaining number of quantity and the item data that it picked up initially. And yeah, that is it for the logic. Pretty simple, right? Now let us code it out. First, let us complete our pickup item code from the previous part. Firstly, in our inventory add item function, we change its return type from void to int, and after the end of the loop, we return to the player the remaining number of items that we were not able to add. Back at the player side, we first register these remaining number of items, and if they are greater than 0, we go to our player's hand and run its drop item function by giving it the item data and this remaining number of quantity. To implement the drop item code inside player's hand, we first add in the reference to our world item scene, and upon receiving the drop item request, we instantiate it inside our world tree right in front of the player. With this, the pickup item logic is now complete. Now let us code out the remaining drop item logic, which was the actual point of this tutorial. Back in our inventory, we make the remove item at slot function. This will be called by the player whenever they want to drop an item. In this, we basically just get the slot index, delete that particular slot, and send the inventory change signal to our UI to update itself. For the purposes of this demo, for the player to get this particular slot index I will make a helper function in the inventory that will return to the player the first item among the inventory slots that is not empty. This way, the player will always be removing data from that first slot that contains an item. Of course, it is only for the demo. You can change this slot picking logic as per your game, and you will learn this logic later down the line in the remaining parts of this tutorial. Anyway, finally, back to the player. We run the drop item function whenever the player taps the drop item key. Inside this, we get the slot that we want to remove the data from, and just remove it by calling the remove item at slot function from the inventory, and then instantiating the corresponding world item by calling our hand's drop item logic. And yeah, with this we are done. We have now successfully implemented the drop item logic of the inventory system as well. Hope you guys like this part. In the next part, we will talk about mainly of how we can use our mouse to control items in and out of our inventory. So stay tuned for that. And in the meantime, don't forget to like and subscribe and comment to boost the algorithm. And I will catch you guys the next time. Okay, bye. Welcome back. In this video, we will learn how to implement mouse-based movement in your inventory system, including dragging and dropping items within the inventory and splitting of items into two just like in Minecraft. This is the last part of my multi-part tutorial series of making an inventory system in Godot. In the last part, we discussed the code architecture and the logic behind picking and dropping items in and out of inventory. And after today's part, you would have successfully made a clean and scalable inventory system for your game. So now let us first start with the logic behind dragging and dropping and then item splitting. Let us say that you want to drag data present at index I and drop it at index j. The first thing that we have to do is to show a preview of the inventory item present at index I. This is done to show a visual feedback to the player of the stuff that they are dragging. And we will be using Godot's built-in API to facilitate this dragging and dropping and as well as showcasing our preview. Now for the actual drag and drop logic, we will have certain cases based on the conditions of inventory items present at index I and j. Firstly, if our j slot is empty, we will dump whatever data we had in slot I onto j. If the data present at index j is not the same as the data present at index I, that is, we are comparing a sword with a wood, we would be swapping the data present at both of these indexes. That is, we will swap I with j. Lastly, if both of them contain wood, we will try to add whatever quantity of I we can onto j, until and unless, of course, we hit the max stack limit. And if we have still some quantity of items left, we will dump them back at their original position, that is at index I. Hopefully you guys understood this. Now let us code out our drag and drop logic. Everything begins inside the inventory slot. We first register a signal that we will emit whenever we drop a data that we are dragging onto a inventory slot. This signal will be captured by our inventory backend via the UI to actually facilitate the drag and drop logic. And that is really how any UI or frontend should be made. That is, the data heavy portion should always be handled by the backend, with the front end being only a tool that will react to these data heavy changes done by the backend. Anyway, to begin our dragging, we will rely on a built-in Godot's API function called getDragData. This function runs for every UI node whenever we hold and drag our mouse on top of it. And this function must return whatever data we want to hold on to whenever we are dragging our mouse. In our case, the data we want this function to return, that is the data we want to hold on to while we are in our dragging motion, must be this particular inventory slot, as this object not only contains our inventory item but as well as the slot in which this item is present. Secondly, Godot also allows us to show a preview of the data that we are dragging. This is done by the setDragPreview function, in which we feed in the control node / the UI node that we want Godot to show whenever we are in our dragging motion. In our case, it will be a visual replica of this inventory slot, that is, a texture rect containing this inventory's icon as its texture. Okay, now we are in our dragging motion and we want to drop a data onto this inventory slot. For this, we have to firstly tell Godot the condition that will make this particular drop valid. This function might not seem that useful right now, but think, what if your game has two different menus with two different drag and drop mechanisms? I'm pretty sure you would not want to drop items present at menu 1 onto menu 2. In that particular scenario, this function becomes very useful, as it will then not only help prevent data corruption, but as well as prevent unexpected run errors. Anyway, our check is pretty simple, and we will drop our data as long as the data we are holding is a inventory slot. Finally, what to do when we drop our data? Nothing, we just emit our signal that we defined earlier and share two parameters. First being the data that we are holding on to, and that is the initial slot I, and the second being the slot on which we have dropped this data onto, that is slot j. Essentially, we are sharing our starting slot and our ending slot. Now back to our inventory UI, we firstly connect this particular signal onto a function, and inside this we will just ask our inventory to handle this drag and drop by sharing our slot I and slot J's index. Now finally back to our inventory's backend. Firstly, if either of our starting and ending slots are empty or are different, we will just simply swap both of these slots. If neither of these three conditions are true, then only the last condition remains, that is, both of these slots have the same item type. In that case, we'll firstly try to fit in the data of slot I onto slot J. And if you still have some items left, we will just dump them back onto slot I. Oh, and by the way, here is a swap slot function. Pretty simple, as you can see. I do not know what to add here. With this, your drag and drop code is done. We can demo this out and you will see everything is working correctly. And now let us move on to item splitting. And that is a more complex part of this tutorial. Firstly, the logic. The first thing we do whenever we are about to or are splitting an item is to disable our drag and drop logic, as I do not want these two mechanisms to cause problems with each other. And in our code, we will use the can drop data function for this part. So what happens whenever we try to right click onto a inventory slot? The first thing we do is to split the item's quantity in half and start holding onto the other half of the item. Now let us say we bring this held item and right click it into another slot J. And same as before, we will have certain scenarios based on J's condition. If our J is empty, we will put in one quantity of the item we are holding into J. And secondly, this will also be the same case if the item type that J has is the same one that we are holding. And thirdly, if both of these item types are different, then we do nothing and still keep holding on to our held item as it is. Okay, so this is it for the three conditions. If however you do not like what I am doing in any of these three scenarios, then feel free to change the result of these conditions on your own. You are now well versed enough to code all of this logic by yourself. For all I care, you can put all items you are holding onto J if J is empty instead of 1. Okay, so anyway, I will be coding this logic out. Feel free to experiment this based on your own game. Okay, now let us move on to the code. This time our code begins from the inventory UI, where we will make a variable that will be used to store the held item we will be using for our splitting operation, or in other words, the item that we will obtain when we right click onto a inventory slot. After that, we will make a boolean function that will return whether we are holding this item currently or not. This function will be used by our inventory slot to disable their drag and drop mechanism, which we will talk about later on. Speaking of later on, we will also connect a signal that our inventory slot will emit whenever we right click onto it to a helper function to handle this right click event. Oh, and same as before, we will let the inventory backend handle the actual logic for this, with our UI only reacting to it by changing its held item for split variable. Oh, and as a side note, we will send to the inventory the current item we are holding and as well as the slot we have right clicked onto. And before moving on to the backend, we will complete our front-end flow by wiring up our inventory slot code. Inside the inventory slot, we will first make it unable to drop any data if our UI is currently holding any item for the split operation. And finally, we will write the code to emit the right-clicked signal whenever we right-click onto a inventory slot using the built-in GUI input function. Now let us finally look into our backend. Firstly, if both our held item and the slot we have right clicked onto are null, it means that our split operation is null and void and our inventory UI does not need to hold any item. Otherwise, if only our held item is null, then that means we are initializing the split operation for the first time. Then that means we must split the quantity of our slot index in half and give the other half to our held item. Care must be taken when we are dealing with odd number of quantities. In that case, then either the slot index or the held item can have the greater half of the quantity. In my implementation, that is the held item because it is the core focus, but you can change this as per your game. And lastly, if we are already having a held item, then we'll try to add one quantity of it in case the slot is either empty or of the same item type. Based on all of these scenarios, we will develop our new held item and return it back to the UI. Where, and I assure you this is the last part, we will preview it using Godot's built-in draw function. That is, if our held item is not null, we will draw a rectangle made up of our held item's icon and as well as draw a string showcasing the remaining quantity. Since this draw function must be updated every frame, we will refresh our inventory UI every frame in case we are having a held item. And with this, our inventory system is done and complete. Congratulations you guys if you have made it till here. This tutorial was not at all easy. Give yourself a pat on the back, for you are now the proud owner of a clean and scalable inventory system. Hope you guys liked this tutorial series. Don't forget to comment down below if you have any feedback or criticisms, and as well as like and subscribe if you guys are already down there. And I will catch you guys the next time. Okay, bye.